Space exploration. So by the end of this lesson, students should be able to examine some of the current hazards and benefits of space exploration and discuss the future role and implications of space exploration in society. So why explore space? So this is JFK, and back in 1962 he gave this speech. So he said, we choose to go to the moon in this decade and do the other things not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills, because the challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win, and the others too. So that was JFK. He made that speech in 1962. So that's him here giving the speech. So 2,500 days later, over 500 million people watched Neil Armstrong and Buzz take those famous small steps for man and giant leaps for mankind on the moon. And that's a picture of this here. So the Americans were the first on the moon. The era around that time, in order to get them from this speech to being able to actually put footprints on the moon, it cost in excess of $135 billion. So it costs a lot of money to make this vision that JFK put forward come true. Now, to put that into context, if we think about the Vietnam War, cost 668 billion. Annual tobacco market worldwide is 670 billion, and these are some of the other events, if you like, and how much they cost. So you can kind of see, like, if a war is costing 768 billion, think about the inspiration that those astronauts gave to everybody when they looked at that and they seen like what was possible. So these were really exciting times, and it's only getting better. So it is in relation to space exploration. So fast forward to this day and age, and we can see some of the like fantastic. So here we have an astronaut up in the International Space Station, and humans are actually quite comfortable now in space in relation to exploration of it. So this here, and what it's making us realize is that the universe is very, very big. So these are locations of Kepler planet candidates. So when we started to develop like really powerful telescopes and like things like the Hubble Space Telescope, and we're able to train those out into space and have a look, what we can see here is that there are hundreds and thousands of planets. So if you were to take a grain of sand and you were to put it on your finger and you were to put it out in front of you and look at that grain of sand, that's roughly like, if we look at this image here, that's roughly like the amount of space that we're actually looking at in comparison to the size of actual space. So it's a tiny fraction, but what we're seeing in these tiny fractions are all of these circles here are planets. So they are. And some of them are Earth-sized planets and Earth-like planets that are very similar to Earth. Also as well, like what space exploration has given us, not only like inspiration and it's also given us, we've been able to look back. So images like this here, we're able to actually look at the world from space and take, a really broad perspective of the Earth and study the Earth from space as well. So if we look in this image here, we can see that we have a hurricane that's heading towards the Philippines. And by having like the International Space Station in space and we're able to observe what's going on, particularly weather systems on Earth, we're able to give early warning of events like this. So for example, we can give early warning that we have these massive weather systems that are going to hit the coasts, and what that does is it gives the people that are living in those coastal areas time to evacuate and potentially saving thousands of lives. But also as well, it gives us a unique perspective. It enables us to be able to study these phenomena and understand them in more detail. So this here is a very recent image that was sent by the what's called the James Webb Telescope, and this was only like literally taken a couple of days ago. And the predecessor to that was what was called the Hubble Telescope, Hubble Space Telescope, and these are telescopes that look out into space. Now, James Webb Telescope is actually, it's able to capture way more detail than the Hubble Space Telescope. And this is one of the images that literally has just come out. And what this will enable scientists to do is to study the universe in more detail and gather more information about the universe. So we can gather information like this. So this is basically all of these clusters here are galaxies, and what you have here as well is nebula and stars. Also as well, what this here is, this is an asteroid, and what we're actually able to do now, and what we're in an era where we can actually start to think about mining asteroids. So for example, being able to land some kind of machine on these asteroids and mine them for minerals and raw materials that we can use, for example, back on Earth. So it's very exciting times now in relation to space exploration. And what it does, like what JFK said, by humans engaging in this activity, we are advancing ourselves and advancing technology as well, and advancing our understanding as well in relation to our place on Earth. Like if we look at something like this, it makes us realize that, we need to look after the Earth that we are on. It's a tiny little blue dot that we all inhabit. Our whole lives are spent, everyone that we know and all our life is spent on this planet. So we have to look at it and think about looking after it. So what is out there? So since the time of the first explorers, so such as Christopher Columbus, humankind has been fascinated by the unknown worlds that lie beyond our horizons. So at one point it was the Americas, for example, whereas now it's like the depths of space. One of our greatest wonders lies in the worlds beyond our planet and what possibly may exist out there as well. So if we think about our galaxy, it's just one tiny galaxy in amongst billions of other galaxies inside a massive universe. So there's huge unknown frontiers there for us as humans to explore. So our history tells us that it was during the Cold War, a period of time uh, beginning in the late 1940s, when the United States and Russia had a very difficult political relationship with each other, that some of our greatest achievements in space exploration took place. So the Americans were terrified that the Russians would dominate space, and as a result of that, there was like a space race, if you like, to get the first astronauts into space. The desire to explore space was called the race to the moon. Both Russia and the United States wanted to be the first country to land astronauts on the moon. So again, this gave a massive focus to both societies, the American and the Russian societies. So it was during this time, so in around 1958, that the National Aeronautic and Space Administration, or NASA, was started, and its main mission was to ensure that an American astronaut was the first human to set foot on the moon. So that's why it was set up. NASA was set up to achieve that goal. So even though a Russian, Yuri was the first human to orbit Earth in 1961, the United States won the race for a human to walk on the moon 8 years later. So on the 20th of July 1969, the American astronauts Neil Armstrong and Buzz Aldrin stepped onto the moon, announced to the world that that's one small step for man and one giant leap for mankind. And it is this giant leap, the leap into space exploration, that we will be focusing on in this particular chapter. And we will be looking at what we have learned from our journeys into space, so what has come about as a result of this. So in 1961, Yuri Gagarin was the first human to orbit space, and he was a Russian astronaut, and this is a picture of him here. On the 20th of July 1968, the American astronauts Neil Armstrong and Buzz Aldrin stepped on the moon, announcing to the world that's one small step for man and one giant leap for mankind. So what are the benefits of space exploration? So in developing rockets and shuttles that could be launched into space, scientists were driven to make computers and digital technology that was small enough and light enough to fit into spacecraft. So spin-offs of the research into technology for the space program have benefits for the rest of us on a day-to-day basis. So by scientists pushing this, like our understanding of science and trying to get astronauts into space, it meant that they had to develop a lot of new technologies and novel technologies. So what are some of these technologies in some of the areas, and these are directly impacting on society now? So nutrition. So food in space must have a long shelf life. Food needs to be nutritious and stay edible for long periods of time. So this need led to the development of long life foods, which we now find on our supermarket shelves. So for example, powdered foods such as soups. So powdered soup, for example, they're like a direct spin-off in relation to nutrition um, from the space programs. And there's lots of other types of food like this as well, but this is one particular one. There's also been huge developments in industry. So in spacecrafts, all piping has to be lightweight but extremely strong. And this had to be developed specifically. This form of piping is used now in industry. So for example, heat pipes are now used in computer systems. So the piping and technology that they use, this lightweight material that has to be able to withstand extremes of temperature, is now used everywhere by industry. Along with piping, cordless tools that were developed for space shuttle use are now also widely found in ordinary households as well. So, like tools like this that we're able to use on a space station, for example, that they're lightweight and easy to use, and they don't need to be plugged in. And also as well, the use of robotic technology, which was developed for spacecraft, is now also used in industry as well. So a lot of the car manufacturing industry, for example, would use these robotic arms, and they were initially developed in order to help in relation to the space program. So in medicine, so heart monitors, which are used in all hospitals everywhere across the country, were developed to observe the heart rates of astronauts on missions to space. So again, these astronauts would be uh, a lot of money would be invested into them, and they want to make sure that they're healthy and being able to keep track of their vitals. So that's where these heart monitors were produced. They are now used in all hospitals. There's also like huge development in materials. So the safety of astronauts was an essential part of all development. So getting astronauts into space and then getting them back down safely was the number one priority in relation to the space programs. So to do this, materials that astronauts wore needed to be fireproof. Firefighters now wear protective suits made from materials used in spacesuits. So those materials are had directly benefits in relation to firefighters being able to use them. Spacecrafts have spacecrafts have to endure some harsh conditions. Materials used in spacecrafts need to be able to withstand extreme changes in temperature and are now used as fire resistant materials in new homes as well. So, ceramics and materials like that, for example, they have to be able to withstand extreme heat and extreme cold, and those materials then can be directly used then in, for example, the construction industry. So mobile phone cameras. So the cameras on our mobile phones are a result of technological developments of cameras in spacecrafts. So the development of these cameras and the lenses are a direct result of developments in the space programs. So computers, to ensure spacecrafts were light enough to be launched into space, all computers on board needed to be very lightweight, and this lightweight technology has been applied to all computers that we now use. So even a mobile phone now is a mobile computer, and the technology that goes into providing those computers and mobile phones is all a direct result of space program development. So apart from all the amazing technologies that have that has been and continues to be developed, it was the excitement that came from our interest in space exploration that attracted people to study and take up careers in science, technology, engineering, and maths, or STEM subjects, as it is sometimes called. So, space exploration has also enabled us to use technologies to look into space and to look from space to monitor what is taking place on Earth and outside our planet. So it has helped to develop the scientific method and the use and the take-up of studies in the sciences. So a range of benefits has resulted from space exploration, but what are the dangers of space travel? So we've looked at some of the benefits for society and how it impacts on society. Now we're going to look at like some of the, it's not all plain sailing, there are risks associated with space exploration. So what are the hazards of space exploration? These are hazards in space exploration. Throughout the history of all space travel, there have been many disasters. So some of the disasters in space. So the most famous and most unfortunate disaster resulted in not only a loss of the spacecraft, but sometimes the loss of the crew as well. So Apollo 1 in 1967, all 3 astronauts were killed in a fire in the cockpit during pre-launch testing. And that's an image of it here. So that's a very, very sad time. Apollo 13 in 1970, an oxygen gas tank exploded on the command module part of the spacecraft. This meant that the astronauts could not land on the moon as had been planned. The crew suffered great hardship because of the problems, but they all returned home safely as well. So in these attempts to land on the moon, there have been a lot of disasters in space because it's an extremely dangerous undertaking. And at the time, scientists and astronauts were learning basically how to be space explorers. So a lot of risk is associated with that. So then again, the Challenger space shuttle in 1986. So just 73 seconds into liftoff, the shuttle exploded, killing all seven crew members. So this is an image of it. So it exploded and killed everybody on board. The Columbian space shuttle in 2003, the shuttle broke apart on re-entry to Earth after a 2-week mission. All 7 crew were killed as well. So again, it's extremely dangerous trying to get outside of our atmosphere, but then also trying to get back into our atmosphere as well. So some of the health risks then. So when astronauts are up in space, so humans are not designed to, we evolved on the Earth. The Earth is where we've evolved over thousands of years. So space is not a place that supports life, if you like. So astronauts risk their lives, but there can also be a risk to the conditions of their body after a mission to space. So the condition of their body can deteriorate. So our bodies are designed to work on Earth in response to gravity. When we lift anything, our muscles need to apply strength to pull an object against the effect of gravity. This makes our muscles and bones strong. Okay, so there's that resistance that keeps our muscles strong, and that's as a result of the force of gravity. But in space, there is a lower effect from gravity. So once you get outside the Earth's atmosphere, the force of gravity by the Earth is greatly diminished. So there's very little resistance. So according to scientists, space is not an environment we are evolved to survive in. Scientists have spent years studying the effects of being in space and the reduced gravity experienced within spacecrafts on the human body. So what are some of the effects that space exploration has on the body? So if we take bones, for example, when astronauts are floating around in spacecrafts, they're not using their bones in the same way as they use their bones on the Earth. As a result, astronauts will suffer from bone loss in space as their bones are no longer experiencing the resistance or pull from the Earth's gravity, and so they have to exercise carefully. So again, when we move around, what's happening is there's resistance against our bones because of gravity, and that helps to keep the bones replenished and keeps them healthy. Once that resistance starts to go away, the body stops making the bones strong, and what can happen is the bones can lose density and become brittle. So loss of bone density will begin to occur after only 1 week in space. So bone loss occurs when the rate at which bone is absorbed into the body is greater than the rate at which bone is being produced. As a result, the bone becomes weaker. So that's a major problem for astronauts who spend time in space. The same thing then in relation to the muscles. So here we can see like 2 astronauts, they're in zero gravity. So there's literally no force of gravity. They just float around in space. So the muscles in the body shrink in space, leaving the body weaker when the astronauts return to Earth. So what happens is if your muscles aren't being used, they start to atrophy and they start to break up. So that can be a major problem for astronauts. So the immune system. So long missions to space cause the immune system to be less effective at fighting off infections. The circulatory system, or the heart and veins, for example. NASA says that being in space is like standing on your head. Blood collects in the upper parts of the body, resulting in increase in blood pressure. So again, blood doesn't flow around the body exactly the same way it does on Earth. So as a result, that can put pressure on the circulatory system. So again, humans are not designed to be in space. So these are all challenges that humans have to try and overcome. Astronauts have to try and overcome when they're exploring space. So the heart does not have to work as hard in space as it does on Earth. So it doesn't have there's not that same force on the blood of gravity acting on that, offering that resistance. So this may sound like an advantage, but it is very dangerous, as the heart may become weaker if it is not worked hard enough. So when the heart, in order for it to stay strong, it has to be worked against gravity here on the Earth, but that goes away when you're in space, and that can result in the heart becoming weaker. Sleep patterns: there is constant noise and light on a spacecraft, which make it very difficult to sleep. Radiation: so once you're outside the atmosphere, you're exposed to the full radiation of the sun. So astronauts are exposed to one of the greatest dangers in space, which is radiation. Astronauts have experienced flashes of light inside their eyelids. This comes from the increase in cosmic rays that are actually passing through them at greater speed. So literally, these cosmic rays can actually pass right through the body, and they can actually pass through the brain, and they can cause these flashes in the astronaut's eyelids, which it's radiation. The body is not designed to be taking that type of radiation. Okay, so the International Space Station then. So the International Space Station, or ISS, was first launched in November 1998 and took 13 years to build. It is a habitable low orbit satellite that has been continuously occupied by astronauts since 2000. The International Space Station is a joint project involving 5 space agencies. So you have NASA, so you basically have the US, Russia, Japan, Canada, and Europe. The International Space Station has been visited by astronauts from 14 different countries. By November 2014, the International Space Station has taken part in 100 Russian launches and 37 space shuttle launches. So the International Space Station allows us to have a constant human presence in space, and it allows crew members to conduct experiments while also allowing scientists to see the long-term effects of microgravity on the human body. So it's essentially a lab that's in space, and it allows scientists to further develop their knowledge and understanding of space exploration. So what's the future then? Like, what's the future of space exploration? So where do we go from here? And what are the next destinations that we are looking to explore? So one destination is Mars. So the planet Mars is the next big destination. Recently, NASA sent probes successfully to the planet. NASA has launched their InSight Mars lander on May 5th, 2008, and then you have the one that's gone recently there as well, the Curiosity. And the probe is stationary, and it is studying the composition of Mars. So the latest probes that have went there are able to go around and observe and listen and take samples and see what's going on in Mars and be able to help humans to explore it. So that's the next kind of place that humans want to go to. So you may wonder why Mars is the next planet scientists want to look at closely. Apart from Earth, Mars is the other planet in the solar system that could possibly support humans living on it. So it's not ideal conditions, but it might be conditions that humans would be able to survive on. It is a planet rich in the elements carbon, nitrogen, oxygen, and hydrogen, all of which we need to survive. So it has those core elements that we need in order to be able to survive on Mars. Also, Mars has one key element that makes it a possible planet for exploration. It has water. Although the water is frozen as ice, the key fact for scientists is that it has water. So again, if there's water there, the water is going to be a very crucial element if we want to try and colonize Mars. Now, it's no easy feat, and SpaceX and Elon Musk they have a mission to try and do this. The journey to Mars takes approximately 6 months. So this is 6 months of traveling through space with all of the hazards that are associated with that. Astronauts would need to remain on Mars for 30 days or 300 days. So it's 30 days or 300 days. These might seem like odd lengths of time, but the orbit of Mars around the Sun does not exactly match that of Earth. So there will be a window of opportunity for astronauts to return to Earth at 30 days. If this was missed, the astronauts would have to wait for another 270 days for Mars to have completed its orbit around the Sun and be in the correct position again to exit Mars and return to Earth. So it's no like joke in relation to how far away it is, and it opens up all kinds of hazards and problems for humans. Scientists are very aware that long stays in space badly affect our bodies. Overcoming this problem could be one of our greatest difficulties for prolonged space travel. So the other kind of futures are minerals. So another area of space exploration scientists are looking at is minerals. There will come a time in Earth's future when our mineral resources will run out, and we need to begin to explore new areas and possibly new worlds that have high quantities of minerals. So mining asteroids is one thing that we can do in relation to that. Research on research on meteorite collisions with Earth have shown that these asteroid rocks from space are rich in minerals. So NASA has developed a program called the Asteroid Redirect Mission. It is NASA's intention to move an asteroid close to the moon and allow astronauts to explore it. This mission they hope to have launched by early 2020. Okay, so that was their plan. So summary then. So humans are curious about what exists beyond our planet. We have questioned, explored, and discovered vast amounts of knowledge because of this thirst for information, yet we still crave and desire to know more. We keep looking outwards towards space and the infinite possibilities that exist there. It is humans' drive to seek out the unknown, and it is this that maintains our constant search into the worlds and galaxies beyond our own planet. Our relationship with space can be summarized by a quote from the famous Star Trek TV series: to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. And that's the promise of space exploration. Okay, so that is that. So what we've looked at, so we've examined some of the current hazards and some of the benefits of space exploration, and we discussed the future roles and impact of space exploration on society then as well. Okay, so thank you for listening.